Yeah, it was crazy. Yeah.
I know, and this is what I'm like.
Yeah, so I don't know
you
what you
know
can
about
do for me.
resonate.
Yeah.
This is the premise of what they do.
Thanks everyone for coming out.
I was curious.
How are you? Tim and Leo, they've been working on. But first, I just want to talk a bit about the group. We are the Vancouver Creative Technology Meetup, and we use technology for creative expression and anything that's even vaguely related to that. So today we're going to have the main presentation from Tim and Leo, and after that we'll open it up to TED Talks. For those of you who are unfamiliar with TED Talks, we plug in, like anybody can just plug their computer into the projector for like 5-10 minutes and share the stuff that you've been working on that's related to creative tech. Washrooms, you can go out these doors and go that general direction. What else? Snacks, please help yourself. There's still some ginger ale and soda water. And we have a Facebook page and a Slack channel. If you're not on there, you should join up and hear what's on there. So yeah, without further ado, let's hear about LightWork.
Hey guys, thanks for coming out. I'm Tim.
I'm Leo.
And yeah, we've been working on some software that we hope will help artists create interesting things with LEDs. So, a bit of an overview, kind of talk about who we are, the concept for the project, a bit about our process. We'll do a live demo, go over some of the challenges that we've encountered, and then talk about what's next for the project. So, I'm TimRolls. I studied exhibition design at Grant MacEwan in Edmonton. I guess right now my focus is mostly on interactive art and immersive environments. This next point I kind of put in there, for me, I never really considered myself a coder, and I still kind of don't. I'm not really a programmer, even though we're doing these things. Didn't really click in my head until I did, with a friend of mine, we did a challenge. We made one piece of generative art per day for a year. Really forced me to actually figure out what was happening and think about it. And yeah, so I include that point because I think there's a lot of people in the creative side of things that have a limiting belief about whether or not they're a coder. I think everybody can code if you just put a little bit of time into it. And I founded Art Not Ads with a couple of friends from school. It's a collective. We use our design superpowers for good. And I also started Powerful at Maker Labs with Derek, over there, which is intended to take on bigger projects like public art and installation work, to kind of use the resources that Maker Labs has to build bigger things, this project being one of them.
Hey, I'm Leo. I did my Master's of Fine Arts at Emily Carr. I focused on really new media things. I did a lot of programming, and the main focus was sort of the relationship between sound and sight, so audio and visuals, and how they sort of enhance each other, and perception and consciousness, so all of those things together. Currently, I specialize in data visualization and sonification. I do all sorts of stuff with scientific data, one of my current projects is visualizing particle collisions. Some of you may have seen that project in the last TAD Talk. So yeah, I focus on art and science, interactive installations. I'm one of the co-founders of Generate app, which is an iOS and Android app for sort of making it easier for people to make video art on your phone. One of the co-founders is here as well, Jesse Scott. Yeah, so that's basically me.
All right, so concept for this project actually started as a result of some of the things that Maker Labs tends to inherit. So this was, last year, this piece was at Maker Labs. It was used for a previous installation. Initially had like candles in the holes. It was a totally different art installation. And you know, Derek had the idea of, why don't we try to make an LED wall out of that? So that led to the eventual realization for the problem that we tried to solve with this project. So I did some research, did some testing on some LED things, some different ways to approach it. And for the most part, if you're trying to work with LEDs, every bit of software or library that exists to help you do that basically assumes that they're going to be set up in a straight line or a grid, which is basically a bunch of straight lines. As soon as you try to go outside of that, it gets really weird. So, like for example, you can see like, you know, if you were counting down these LEDs as they're connected, like 1 to 9, it's pretty easy to see, you know, how you would expect the output to be coming out on them. Same with once you get into a grid, you know, it's basically just like a zigzag pattern. You know how long the lines are, so you can program that pretty quickly. But then, you know, as in the R for the future wall, it gets a little more complicated, I guess. And so again, you know, these are physical strings. They have to be connected in that way. Unless you want to get into some crazy soldering, but so, you know, if you're numbering them sequentially as addresses, you start getting like, you know, number 30 is next to number 2, and number 5 is next to number 18, and it starts to be a bit to juggle. And then multiply that out. You know, the more complex your installation gets, it starts to be something that you don't really want to have to do by hand. And so that became the basis of the concept for this project, trying to find a way to solve that using computer vision. And I think the key word that I keep going back to when it comes to making decisions about the project is accessibility. Always making decisions to try to make this as accessible as possible. So this image is like the concept render that I did last year for the grant that we submitted to Creative BC. So there's 3 components to this project. This is actually just the first one. So it starts out with the LED mapping software. Once we have that, the ideas will coming up in the next phase, starting in January, we'll be working on a site-specific installation using the software, something that we might not have been able to do without it. And then from there, we'll be putting together workshops to disseminate and teach people how to use it. It's free, open source, so anyone can use it, contribute. So a bit about our process. Started with research last year in kind of getting started with Powerful, wanting to make some digital things, some spatial things, interactive things. I started trying to figure out what we could do with LEDs that Maker Labs had kicking around. Tested lots of platforms. Here's a couple shots of using it with Arduino. I don't recommend that. It's really slow. And then on the right, there's a pixel pusher with a whole bunch of LEDs hooked up to it.
What is pixel pusher?
I'm going to show you that in a minute, and there's one on the table right there, but it's hardware for driving LEDs, basically.
Exactly what it sounds like.
Yeah. So out of that research, the best things that I found for actually like physically connecting up to LEDs and controlling them in a relatively easy way. First up was fake candy, super cheap, 25 bucks. It's really small, as you can tell. The hardware interpolation and temporal dithering is really cool. Basically what that is if your LEDs just really quickly turn off, it will make them have a slow fade, just really subtly. And it does that in hardware. It just makes your animations and patterns look a little bit nicer. Temporal dithering is, I don't know that exists on anything else that controls LEDs, but basically it's updating the LEDs 400 times a second. And if the color that it needs to produce is not quite like, ultimately you're breaking like RGB values into like 256 colors, right? So say you're somewhere in between 199 and 200, it will vibrate between the two of them 400 times a second to create a color that's in between the two. So you can actually see more colors on your LEDs than, like perceptually, than they should actually be able to display, which is really cool. Downside of this one though is each of these can only run 512 LEDs, which is not actually a lot. Like that sign right there is already 150. And also just made for WS28 10X series, like 11 and 12s. So other LEDs don't actually work with fake candy. So Pixel Pusher was another good discovery that I made in terms of driving these things in a way that's accessible. They go for 120 bucks, so more expensive, but they have built-in connectivity over network, so that makes them really easy to access from lots of devices. And it's like an automatic discovery, so you don't necessarily have to know what address it's at. It'll find it automatically. It does power distribution for you, so you don't have to necessarily be making janky power distribution circuits yourself. That's just handled up to 20 amps for you. So for the most part, that's all the LED power you'll need off of one of these things, barring a few weird things with really long strings. But this one supports way more LEDs. Like each of the 8 channels can almost run as many LEDs as one fake candy. So you can, if you were to, group together a few pixel pushers, you can easily get to 10, 20,000 LEDs with these. And downside on this guy is that it actually doesn't like working with the WS2812s, 11s, basically the cheap LEDs that exist. So it'll be pretty finicky if you're trying to run it with those. It likes to run with the more expensive, faster chipsets, like LPD 8806. So kind of a downside if you have those.
We use those with AKA 102s.
Yeah.
Then they're not quite as expensive.
Okay.
Which ones are you using here?
Those are WS2812s. That string happens to work. They don't all happen to work.
Yeah, we have another installation at work that does not work with the pixel pusher, so we have to use that fake candy with that.
So around around the time that I was doing this research, I was looking into grants we could use to support the growth of what we're trying to do with Powerful. I found the Creative BC Interactive Fund grant, which is actually, the deadline's coming up soon here on December 12th. I recommend checking it out if you have any creative tech projects that you wouldn't be able to fund yourself, basically. So yeah, creativebc.com. I think that they really like funding projects that contribute to the community in some way. Not necessarily just, you know, an artist making stuff in the studio, but something that other people can enjoy or use. Definitely like things that will be shown in public at some point.
Interactive? Or?
Yeah, it can be, but they also fund like new media stuff as well. Like the Interactive Fund is one, but they have a bunch of different grants. So definitely check them out. So basically, as a result of you know, doing that research at this time, right about the time that their deadline was coming up, it's basically what made this project possible. So that was sort of last year. The process of getting the grant went from, you know, November, December of last year, applying to actually getting the grant in August of this year. And then this is kind of like a rough outline of the development of the actual grant project. So first half, we basically just start out with developing the software till December here. And then the second half we'll be working on the installation and documentation and all of our workshop stuff. Yeah, this is something that we've tried to, I guess, embrace in our process. Spiral design paradigm, and I think this is described in a lot of different ways when it comes to like design work. This one is a little more specifically related to tech projects, but I think it just relates to projects in general. I think the idea is you kind of, you know, analyze the problem that you're trying to solve. If you follow this cursor here, if you follow this, this is kind of like your starting point in the middle. And as you go out, it's out from the middle, it's sort of increasing in time and complexity. So, you know, you kind of start out by like analyzing a problem, do an evaluation, kind of figure out where you might want to head with it, do some development, kind of get to a point where you have something to show for that research, do some planning for what's next, and then it sort of cycles onto itself. You analyze, you know, the results of what you did, evaluate that, do some more development. Now you're more complex. It's stuff that's going to take more time, and then you can kind of build on the smaller pieces that you've built as you get to the more complex stuff farther down the road. So this is how we've been trying to go about doing these things day to day. And then yeah, we're collaboratively coding this. We try to split it up for the most part. Leo's been awesome on the sort of data science side and doing the decoding stuff. I've been focusing on UI and making it work like cross-platform. I think we'll talk about that a little more in the challenges section. But so yeah, do a demo and show you what it is.
Work. Yeah, you could. All right, so let's go down. This is the main processing sketch. Eventually, this will be hacked up as an application that you can just open and run without even having processing running. But this is open source, so you can get the code right now and can read it, and it should run without any issues. So this is our current interface. Start by loading up the camera. So there's a camera there pointing to the little LED installation. So we see that here. Then we choose our driver. So we have two connected drivers. The pixel pusher, which is driving the pile of LEDs there, which I'll demo later. We're going to start with the Fade Candy, which is driving the LightWork installation. So then we connect. Here I can set the IP address, how many LEDs I have per strip, and the number of strips. So I don't need to set these now. These are conveniently initialized at the right values. So now we're gonna do a little calibration. So this side here, on the right side, is basically our open CV, or the computer vision output. And we want to adjust a couple of things here. First of all, you see that on the left-hand side, when there's a lot of light going on, the LEDs blend together quite a bit. So we want to take down the brightness so that we get more nicer, like contained blobs. You can also see that reflect on the right-hand side. We can play with the threshold, sort of fine-tune things depending on our situation. Sometimes you have quite drastically different lighting conditions that you weren't expecting, and in the process of developing this, sometimes I had things working really nicely in the morning and everything would break in the afternoon because of different lighting conditions. So that's a consideration. So this should be sufficient. Let's see if we can take this down a little bit. So we're done with the calibration, and then we do the mapping. So the mapping procedure that we're doing now is, see all these blinking lights? These are actually binary patterns. So a light on is a 1 and a light off is a 0. So we've actually assigned a unique pattern to each address, LED address. So each of them is gonna flash a unique pattern. During each frame of the pattern, we're gonna capture one image, and then we have a sequence of image that we then go through, and then we look at each LED that we detect and decode the values from there. So let's give it a try. Now we're grabbing all the frames. Now we're doing the decoding. You see it detects all these blobs here. And then we see red circles on the outlines of each of these. So these are all the detected LEDs. And then we save it. And now these are saved. So we can now safely stop this. And now we're gonna launch the counterpart of this. So this.
Can we try the one that's not mapped first and then do the mapped one?
Sure. Okay. So let's see. So Tim was asking me, can we see a version of what I'm going to show you that is not mapped? Just to illustrate that, you know, if you just try to put an animation out to a grid, and if we treat this as a grid, what would that look like? So we're going to do the same animation on two things here. So this is a grid. Each little dot here is an LED. And then we would expect the line to like scan over this area and light them up linearly like that. But it's not actually doing that right now. So that's the reason why we're doing this. So that was the demo of the broken thing. And now we're going to demo the unbroken thing, which is the LightWork scraper. So we call it a scraper because it scrapes pixels off the canvas and puts them on the right place, right there. So,
ooh,
yeah. So we have saved ourselves quite some time in making a layout file that sort of addresses, or it gives a coordinate to each LED, and now we can just, we can do this, just light up some things here. We can basically write whatever processing code and put it on there. You could load a video and show it off there if you don't want to code any generative graphics. You can just put your webcam on there. Anything you can do in processing, you can do, and just sample the values nicely like that. So that's sort of the extent of the demo. I want to talk a little bit about different versions. Do we have that slide? Or is that
Yeah, that's
later?
Yeah.
Okay, let's just show you anyway. We've never done this presentation before. Fade candy. So this is like the sequential version. So the sequential version is that basically runs real time, and it basically lights up one LED, figures out where it is, it knows what LED it lit up, so it associates that address with that one, and then when it found one, registered it, and moves on to the next one. So that looks like, let's connect. We are connected. It basically looks like that, and it's a lot slower, and it's not as accurate. Like, we did have a more accurate version in C++ when we were still developing in C++. We'll go over the reasons why we stopped C++ development later. But this is sort of a remake of that, and it's actually been made obsolete by the binary version because the binary version is so nice now that it actually consistently just works. But we just wanted to share this with you as well. Should I do the second part of the demo? Try that? What? The pile of LEDs?
Yeah.
All right. So this may not work as well, but we have some LEDs just to sort of prove our point here. I'm just going to put them on the floor here. Oh, right. Careful.
Thank you, Tim.
Careful. So let's make a nice installation right here.
Yeah, feel free to come up and.
Yeah. So I'm gonna arrange these. I'm gonna try to not have them like overlap too much, because then we're gonna have blobs that connect, and it's basically gonna have a hard time figuring out which is which. Yeah, let's see what the camera's seeing.
We're just going for pure randomness right now.
This thing. So, can you adjust that? Is that possible? Well, you might not get all of them, but
Yeah.
Or just move the LEDs over.
Yeah, that works.
You're going the right way?
yeah, this is fine.
Yeah, that's good.
Okay. And they're, yeah, like that. Okay, so all we do is we select the pixel pusher instead, because this is what's driving it right now. And we connect. Hopefully it connects. We do our calibration. So we're going to try to get this image here to show us distinct blobs. And okay, we'll just try it out. And now we've mapped a whole bunch of them, and we save it out. and let's switch the network interface to Pixel Pusher in the scraper. Run this. So yeah, it kind of works. So that's all for the demo.
That's all.
Can we talk about that some more? Okay.
You covered most of the things there.
Yeah.
All right, so it's totally at a point where it works, but there's been some challenges along the way. So as Leo kind of mentioned, language is one of the bigger ones that we've overcome.
Yeah, it was a big part of the research as well. It was just trying out different frameworks and different languages. Try to pick something that covers all of our needs. So we wanted to start with Python because it's easy and quick to write, but it didn't support everything that we wanted. And then we chose C++, so open frameworks in C++. If you're not familiar with that, it's kind of like processing, but in a more difficult language. So we developed in C++ for a while, and until we were at, yeah?
We basically got it to this point. Like, we basically had the binary mapping stuff working in C++. Problems came with like networking stuff, completely not able to get a connection to a Pixel Pusher, which is one of the interfaces that we kind of chose as wanting to support. What else do we get? Just like libraries in general.
Yeah, I think the main issue for me was like maintaining the project, because we were relying on different forks of different libraries, and then we had our own forks of that we had to do tiny little modifications in. And so if you as a developer wanted to pick up the project, it would take you like a day just to set everything up to compile. And that's not what we want. That's not easy. And you know, a big reason for choosing C++ as well was that OpenCV is pretty much written in C++. So there's a lot more you can do with computer vision there. So porting it to processing included like actually writing some of the like blob management code and all of that, which we didn't have to do in C++. So that was like a week of just doing that, which is actually not too bad. But yeah, right.
That's kind of what we were already talking about.
Yeah, and writing C++ code is generally slower than writing processing code.
Oh, why doesn't that thing work? Oh, you just need to do it completely different for that one kind of variable, because C++.
Yeah, and there's like memory management, and there's pointers, and there's weirdness and stuff that, you know, they're not horrible. I kind of like working in C++, but it's not catering to ease of use and integrating with other like quick projects, which is basically what processing is built to do. Like, they're called sketches because they're like quick sketches of things that you can do, and this way you can easily sketch up little LED installations, and you don't need a lot of you don't need any external libraries to run this. Yeah,
right. Yeah, so UI scaling stuff and cross-platform. So Leo is developing on his Mac, and he has a older Retina display, so it's a lower resolution, and my PC laptop has a 4K display, So in every sense, like what we see when we run this, especially in the C++ version, was completely different. So it's been good in terms of figuring out how to manage that, because we can just test it immediately. But it's been there's been some challenges with that. So this version right now is using the dimensions of your screen to try to scale the UI window. Basically just has like two versions. There's like low res monitor, high res monitor. All the UI elements are kind of like arranged on a grid. Kind of try to treat it like you would do CSS on a web page. Try to get a grid on things. This version, we had to do some last minute changes, so it's not exactly where it needs to be in terms of the UI, but it should look pretty much the same on any system that you run it. Then I guess this is sort of just an ongoing challenge that I don't know if we'll ever fully figure it out, but performance, trying to make it go fast. It's basically how we came up with the binary mapping. You know, we started out with the basic sequential one just to like see if this thing would even work. Then we were thinking about, okay, so you're sitting there for, you know, if it takes us like a minute or two to map 150 LEDs, what happens when you have 10,000 LEDs? What happens if somebody walks in front of it in like the middle of like 5,000th LED and then you need to start over? Starts to be a little brutal. So you know, came up with the binary one to do it as basically as fast as possible, as scalable as possible. And like the more LEDs you have with that one, the more time saving you get. You want to talk about camera stuff in terms of syncing it?
Yeah, so yes, we can talk about the camera. So initially we were doing all this real time, and problem is that I send a signal to the LED, it turns on. 3 frames later, I see that on the camera on my computer. So if I'm updating at anything less than three frames, basically the computer is going to think that I turned on LED number 1, and that's trying to turn on map LED number 1. But in reality, well, basically there's an offset of like what the computer thinks is on and is actually on, and what the camera is seeing. So we can't map things efficiently that way, because there's no synchronization between the camera, and there's also no guarantee that this is always 3 frames. It depends on your hardware setup and lots of other factors. So there's no real way to safely assume a certain lag. So that presented some challenges. Can we talk about what's our next slide? This? Okay.
Yeah. Multiple cameras with the same name. So one of the sort of eventual goals, and this is based on the binary mapping version of all of this. Binary mapping is like the first step, but we want this to work in 3 dimensions. So not just like the flat plane of things, and get like a 2D map, but get multiple perspectives and be able to map 3D arrays of these things. In doing so, as you can see, there's a button up on the top that says stereo toggle there that actually turns on the input for second camera, and you can use that. Problem that we encountered though is, and that I don't know we could have known about this ahead of time, is that ultimately processing is only looking at the name of the camera when you try to load it, and there's no way to override that. So if you have 2 cameras with the same name, it's only try to get the first one. I see you grimacing at me over there. If you have a solution, I would love to hear it. So it's a problem that we've been sort of wrestling with, consulting the internet. What's up?
There is a solution
for
Windows, but it involves editing the registry.
The registry, yes. Yeah, that's not really something I think is viable to ask people to do.
Yeah.
I did see that as well.
You can change the friendly name in that registry.
Right.
And then you can like find that new friendly name.
Yeah, if there was a way to like change the camera's name, like in its firmware, I would probably prefer that than getting people to change their Windows registry and like, whoops, I deleted System 32. Yeah.
I'm just wondering if you could, like, you're using the built-in video library or
Yeah.
GS video?
It's based on GS video.
Yeah, okay.
Have you considered doing the mapping in 2 steps? And
Yes, that's what we're going to try actually to get around this problem, is to map it once, move the camera, map it again. Because with the binary, we not only, like from any angle, we know which LED we're looking at because it has its own unique pattern. That sort of bridges the gap to be able to do that. So whereas with the sequential one, where we're just looking for something on, the binary one, we know which one it is that's on. So we can kind of stitch it together in 3D, hopefully. Jesse?
What if, so if you had maybe, so if this is just a problem with processing the GS video library, and you can't intercept it anywhere, seems weird if you can't, but maybe you can. You could do something like, if it's not a problem with Open Frameworks, write an Open Frameworks camera module, siphon it with processing.
Maybe.
Right?
Yeah. Yeah, I think our next step is trying the like multiple captures thing, and then we'll kind of see how that goes. I think multiple captures opens up more possibilities as well in terms of like what happens if 2 cameras is not enough.
Yeah.
Or what if one can't see all the LEDs?
Yeah, exactly. So what if you need like, you know, to move it 10 times, like you're not gonna have 10 cameras, like.
And is it only working off of system cameras off the USB bus? Is it like network cameras an option, or like?
I haven't tried network cameras.
Yeah.
Yeah, I think that library specifically is set up for USB, but I haven't tried network ones.
Yeah, we thought about it just because of convenience, so we wouldn't have to be plugged in all the time. But then, like, frame sync over network terrifies me as well.
Yeah, sure.
But that's less of a problem with the binary version.
Yeah, so I guess challenges with mapping procedures. We've already kind of been talking about some of them.
Let's talk about, so sequential mapping, I already explained. Color-coded binary is something that I tried before doing basically like luminance-based binary, which you're seeing now.
No, this one was like a sequential thing.
That's a sequential one.
Yeah, and then this guy here was where we were using colors. Yep.
Okay, so the idea about behind this was that I wanted to use like 2 colors for, you know, 1 color for on, 1 color for off. So what you're seeing here is red is on and blue is off, but then you're seeing lots of green as well because you need somewhere to start the frame. Because if you have a string of 0s and 1s, you need to know where to start. Otherwise, your decoding is going to be way off. That actually worked, but it was it needed a lot of calibration around it. And do you have those charts? Plots. To make this work, I actually used Python and Jupyter Notebooks with Pandas, if you're familiar with that. So that's like a data science tool set. So to understand what I was seeing, I was just looking at like one of the LEDs, and then I was plotting the color levels over time. So the idea here is that if I can visually look at this and decode the signal that I know that I'm looking for, I can also make the computer do it. So what you're seeing here is, like the blues here are zeros, the reds are ones, and when you see these green peaks, that's where the frame starts. So we would start the frame here, then we would go 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, and then a start again here. The problem here is that I can't just look at the color value with the highest value, because when I flash the green, I'm also detecting a lot of blues. So what I needed to look at instead is the next slide, I believe, is the difference between like those two channels. So here I know that the difference is very small, so I conclude that it's a green signal, and here the difference is very big, so therefore that's blue. This kind of worked. I was actually very, very happy when this worked, but then later in the day, everything around it became blue. So that like offset the calibration, and things did not work. So this basically relied on too many parameters being tweaked exactly right, so it wasn't very robust. So Derek here suggested we capture a video of just white. So we did that, we captured a video, and then we're trying to analyze that. But the problem was like the frame sync again. So if we wanted to be on for just only one frame, the camera takes a little while to actually like register it like properly. So we need to leave it on for a few frames. But then it wasn't being consistent about how many frames each state of that pattern was going to be, which made the decoding pretty hard. So we came up with basically just turning on a pattern or a frame of the pattern, capturing one image, and then the next frame of the pattern, and then capture another image, and that's what you're seeing here. And that actually worked beautifully. So that's sort of the progression of figuring out how to do this.
That way we only needed to use, or we were able to just use one color as well.
Yeah.
Because we know that the frame we're looking at is the frame that we're expecting based on how much time we're giving it with the LEDs on. So we're kind of just giving it way more time than it needs, and that's sort of the workaround for syncing it properly.
Is the lag different for every frame, or isn't the lag the same for every frame?
It is the same, but it's different for different systems.
But why don't you just calibrate the lag once and then just use that lag value?
It's going to be a setting that you can adjust. So if you set it too low and you're not decoding all your patterns, you can just raise it a little bit. That being said, I don't think it takes a terrible amount of time, even with like we're giving it like half a second now for each pattern. But that's definitely like an optimization thing that we're looking to implement.
Have you thought about using something like MadMapper's spatial scanner? So instead of using live video, it just uses a DSLR camera to take pictures of it, and then you analyze the pictures.
That's basically what we're doing right now with the webcam.
Yeah,
when I was sort of planning this last year, DSLR was actually what I wrote the budget for, because you can like remote trigger, and you know that okay, when I did this is when it triggered. Problem there, going back to accessibility, not everyone has like $3,000 for a DSLR that can do that, but $100 webcam, pretty easy to get a hold of. So
you can even use the built-in webcam on your laptop.
Yeah. So
step away.
That's totally an option. It would probably work, but in terms of accessibility, we wanted to see if we could make it work with this first. Yeah, I think it works. So what's next for the project? So things that we're working on, kind of trying to automate the calibration process a little bit more. Also reworking the UI a bit to allow for, you know, more exposed, you know, variables you can play with to adjust and get your mapping right. You know, it's not going to work in every set of lighting conditions and combination of LEDs, so I'll try to make it as customizable as possible. The 3D stuff that we've been talking about is pretty big. That was part of our initial you know, proposal, so we really want to try to get that finished in the next couple of weeks. ArtNet support is something that we've started on, mostly working on some hardware stuff to get that going. And then an extension of that is we're hoping that the export that we have will just go directly into MadMapper. So if you're using MadMapper and you have some ArtNet devices, it'll just use the map that we generate. And then, yeah, improving the UI, basically. You know, as we develop, we realize we need things, we don't need things, and then it takes a while to pull them in and out of the UI. So, and then, yeah, beta is up now. If anyone wants to grab it, if you have some LED hardware to test it out with, we would love to see how she goes, and yeah, any feedback you have. If you want to give us some pull requests, it's open source, so you know, if it's broken and you think you know how to fix it. Figuring that out in the new year. It's not January yet.
Can you talk a little bit about the BC Creative Fund and how you got it, and what are your responsibilities right now in terms of, I don't know, to them or?
Yeah, so they're pretty chilled actually. Like it's, you know, you got to do a bunch of paperwork up front and like, you know, prepare a proper proposal, budget, and all of that stuff. But other than that, like they haven't really, like they're not expecting like, you know, every week for us to show them our progress or anything like that. They're super hands off. So basically, actually tomorrow we have a meeting with them as like a midpoint check-in to go over our progress basically and talk about the second half. Yeah, they've been pretty good. Took a really long time to actually get the grant from them. Yeah, really long time. Like I think. Yeah, and then we didn't get the money until like August, September, or somewhere in there. You should remember.
Yeah, confirmation in July, right? A little bit.
It's like April.
Yeah, somewhere in there.
It's like April.
April.
Is it April?
I feel like it was in April.
Yeah.
It was really early,
Yeah.
and it took a long time.
Yeah. Yeah, I don't know. Yeah, in terms of like responsibility to them, I guess like they don't really expect anything other than like you are making the project happen.
How do you spend your nights?
Yeah.
So, wondering after the calibration, how do you access each of the individual LEDs? Do you use coordinates, X, Y, or?
It's basically we're finding, so when you see it on the binary one, it turns them all on at once. We're basically getting the general location of each one, getting like a contour for that location,
Yeah.
and then watching that contour to see what pattern happens in that contour. So
Yeah, and then we write it out to a CSV, so you get the LED address and an X and a Y, and right now we have an empty Z variable that's going to also be part of it. We do the depth mapping.
Okay. So if you move your camera, you need to do the calibration again, or just use the phone?
The calibration is kind of just for testing. So it's basically running a similar pattern that you would get in the mapping, so that you can play with the settings, so that the image in the middle that is being used to process for OpenCV looks about right. That's basically all the calibration part is for right now.
So, how you guys wanted to like actually work is you'd set it up somewhere in a control environment, screen test it. Once you have it good, you only have the camera in case something went wrong, something changed.
Yeah,
or like you have to adapt to that environment. Or
basically, you would set up whatever it is that you're setting up with your LEDs.
Yeah.
You map it, and then once you have that map, unless something really majorly changes, you shouldn't have to do it again.
Yeah. One of the things we want to implement is perspective correction. So you may have a big wall and you're pointing your camera up there and everything is kind of bent that way, and that doesn't really fit with what you want to put on it, because you're want to adjust that. So that's one of the things that we want to implement, so that you can just drag the corners around to sort of fix the relative layout of the LEDs.
You get that for free when you do your 3D model, and you can just move the viewport.
Yeah,
true.
But so my question is about the quote-unquote user interface. Are you presenting like a bitmap interface that then like you get a single pixel for each LED, or like a contour for each LED is mixed down, or?
You mean on like the scraper side where you're driving the LEDs?
Yeah.
Yeah, so basically it's just using the coordinates that we've mapped. That comes out as a CSV. And then at those locations, we're doing some stuff to like normalize it so it actually fits into your output window, whatever size that happens to be. At those coordinates, it's just grabbing the current pixel color.
So this is a single pixel that is the closest match for where the US.
Any other questions?
So if your LEDs are diffused, then you're not going to get a nice spot for each LED.
No, that's actually one situation where the sequential one is better. Anything where they're blending together or diffused a lot, the binary one doesn't really work that well.
So like your CV, is it looking for like a discrete blob, or is it looking for a maximum of a particular larger spread of light?
It's looking for a discrete blob. You can do things to manage the size. For example, you can play with contrast, which will lower the diffusion. You can set the minimum and the maximum acceptable blob size. So you want to ignore things that are huge in the background and are moving. You only want to look at like smaller things. So you can set that range that you're looking for. So there's a number of parameters that you can set to help with that. But we've thought about the diffusion problem, which is, as Tim said, probably more suitable for the sequential mapping. Or we would do something like only mapping every other LED and then do the second half, or even split it up even further, just so that they don't blend together as much. And we're actually going to do a test at Tangible Interaction, because they have the Halo wall that you may be familiar with that presents exactly this problem, because those are circles of LEDs with the front panel, and they're lighting on the back wall. So you don't actually see the source of the LED, but you see the glow around it. So that's a really good problem to test.
Have you thought about doing like a hybrid mode where you do the binary mapping, find collisions, and then do a sequential thing after that?
Yeah, we thought about mixing them up in some ways, and I think what we really need to develop something like that is actually work with an installation that presents these problems. We've been scaling up. We started with a really small matrix of LEDs, and then we made that thing, and then we made the future wall, which is kind of like the size of those two displays. So it was scaling up as we go. We still haven't tested more than 150 LEDs, so that's also something that.
Features 207.
All right. No. Yeah. Yeah. Okay. Sure. It's a little bit more.
Same
but it's still not like it's not over 1,000. So I think when we do have something with over 1,000, then you may want to map a portion of them and then move on to the next one. So that may take a little bit longer, but so yeah, scale does present a couple of problems for sure. Jesse?
Is the plan with the scraper, which is kind of handling the rendering, is that always going to be in processing? Is it going to maybe accept other types of inputs, whether that's something like a siphon texture or a drag and drop of a file or like a...
Yeah, you can use any input, like anything you can display in processing will work.
But you have to like modify that code in order to handle.
Yeah, so it doesn't do anything in the draw loop. So basically, anything you draw in the processing draw loop is up to you. It's pretty quick to implement the scraper right now. It's only it's like less than 10 lines. So eventually I want to get it basically like you would use Siphon, which is like a few lines, and then right at the end of your draw loop, maybe you're telling it to send the pixels. That's basically where I want it to be. So we initially talked about porting the scraper out to other languages. As we sort of talked about, that's problematic because the networking stuff doesn't really exist outside of processing right now. And actually writing that would be like a similar scope to this project. So I don't know if we're going to make that happen. But yeah, if you can get a Siphon feed out into processing, you can own this.
You can also just get the LED positions directly, right? You said it's just a CSV file.
Yeah, you can put it into whatever magic you've got going. Anything will read a CSV.
All right.
Right on, guys.
We'll take a break for 10-15 minutes if you want to ask them questions or play with the demo some more, and then start up again for that talks.
Great. Thanks so much. Facebook page. The links.
What?
I want to post a lot of documentation on the Facebook page afterwards. It's like we have some video, right? Or is it just the live stream?
This is so fun. That's like chaos.
I know, right?
I was imagining the installation just hanging like 10,000 LEDs.
We actually talked about just hanging some random arrangements and then like making them actually.
Yes. We were looking at what's that depth camera called we were looking at? What was that depth camera called?
Oh, I know.